terms. Terms, we said yesterday, were the things you see in a polynomial that contain the multiplication and the exponents, and they're separated by the addition and the subtraction. Okay? So, for example, if I have 9x squared, right, should I steal this from the book so I'll know I get the answer right? Sorry. 9x cubed minus 2x plus 1 is my first polynomial. And I add it to 5x squared plus 12x minus 4. Okay, each of these polynomials has 3 terms, making each one a trinomial, as we discussed yesterday. The terms are 9x cubed, negative 2x, and plus 1. Terms here are 5x squared, plus 12x, and minus 4. I wish we had time. I got to rush this a little bit. I apologize. There are some tricks you can use. I will leave them up to you. Some of you in middle school may have learned about drawing terms in boxes. If I have a little more time, I'll go over that. Maybe I will try and set some time for that tomorrow. Pardon? Underlining differently. One idea is to underline each term, bless you, based on the degree of the exponent. The degree of the exponent is the number you see there. So 9x cubed is a third degree term. You may have to go out for a tissue, I'm sorry. Okay, don't have that either at the moment. So 9x cubed is a third degree term. So like Jordan said, I'm going to underline it. I'm going to underline that one 3 times. Based on that, how many times would I underline negative 2x?
Once.
Once, because there's an understood exponent of 1 there. And the exponents are what determine if we can add or subtract the terms. To the 20th? Then I would come up with a different method. Alright, I would not underline it 20 times. Okay, 5x squared I would underline twice. 12x I would underline 1. And the numbers I would not underline at all.
I know what you mean.
So there's no like term.
Okay, yeah. Pardon?
There's no like term.
So like terms, yes. Now, when I have addition here, I can drop these parentheses and I don't have to change anything. And I can rearrange the order on these as long as I keep the pluses and minuses in front of the term. So I'm going to rearrange this as 9x cubed plus 5x squared. I'm going to bring my underlining along for now. Minus 2x plus 12x. Now I'm going to underline these together because they both have 1 underlined. Plus 1 minus 4. Have I correctly rearranged my terms and kept track of the degree of each term?
Yeah.
Can't combine these. They're different degrees. I cannot combine x to the cubed plus x squared. So these stay the same. I'm just going to not underline them now. These I can combine. Negative 2x plus 12x gives me plus 10x. Very good. Plus 1 minus 4 leaves me with minus 3. And I'm done adding that polynomial. Okay? Does that seem reasonable?
Yeah.
Some of them will get uglier tonight. I only have time to do one example each of adding and subtracting, and I need to get on to the multiplication. Follow me over to this board now, Eliza.
Right.
I subtracted the same exact thing.
There's one difference that you have to keep track of.
Can't see.
Okay? There's one kind of important difference here. Now I'm going to subtract the polynomials 2x squared plus 3x. Yes, thank you. You know what? I should write that. Subtracting polynomials. Yes?
When you put the videos up, can you like put the date under which we did it, or like what is?
I've been doing that as a title of like the group of them, and then it shows up when you hold the mouse over it. Then it shows up at the top. I'll show you how I organize it. Come over to my laptop if we have time. And that's okay. It's subtracting them. 2x squared plus 3x minus 3x squared plus x minus 4. Okay. Hold on. Okay, thank you, Eli.
2 papers, actually. My pencil.
Keep that. Keep the pencil.
All right.
All right.
Got it.
Thank you, Eliza.
Yeah.
Okay, now, for this one, same idea. I'm going to underline the squareds twice, the x once, the The squared's twice, the x once, the minus 4, not at all. I'll finish? Okay. And now I will do the same thing, except when you have subtraction and you drop the parentheses,
Can't see.
okay, sorry, it changes the sign of everything that was in the parentheses.
So everything's gonna be negative?
Well, no, because it switches the sign.
You
So,
just said it's gonna switch the sign, so it's gonna...
Only on the right, right?
yes, only on these. Now, hold on, let me think about what that means. Minus 3x squared does become negative where it was positive. Plus x does become negative where it was positive. But Nimi, if you're switching the sign, what happens to the minus 4?
It's plus 4.
Plus 4. So does everything become negative?
Just add it all together.
No, sir.
Thank you. Now, this will become negative x squared.
Is that the thing that changes that you were talking about? Those?
Yeah, just this part. When you're subtracting that, you change the sign of everything when you drop the parentheses. Other than that, now it's the same as the addition. 2x squared minus 3x squared gives me negative x squared.
No.
Plus 3x minus x gives me plus 2x. And I've got nothing to add to the plus 4. Is that correct?
Sure.
You guys think you can handle that?
Yeah.
All right.
Too complicated.
Let me dream, Sarah. Well, yeah, but here comes the fun part. Multiplying, dividing.
Dividing, don't you like flip it?
Oh, we
Dividing's
don't have
gonna
to
get exciting.
learn dividing, right?
Okay.
We don't have to learn that, do we?
Pardon?
We don't have to learn the
Oh,
dividing.
yes, we do.
Why?
Okay. Now,
I'm gonna
Making this so annoying.
all right, but not today. We don't. Today we're
Oh,
not
good.
learning that.
Good.
Okay, multiplying. Multiplying takes foiling to a new level because you're going to multiply possibly more than one of them. I need to do 2 examples of this.
Can you put multiply instead of add?
Thank you. Jordan, you're doing a very good job of tracking my methodology today. I appreciate it, actually. Multiplying polynomials. Okay. Here's what you have to do. Believe it or not, this is the same thing as foiling, but
To an incredible degree.
to an incredible degree. And the letters don't work anymore.
I can't see.
Okay. Now,
Will you change the signs again?
No, it's in the
Hold on.
distribution.
it's distribution. But hold on a sec. Okay, guys. Here's what we have to do in this case.
Only the letters don't work.
Okay, guys. Shh. We don't really have time. The commentary is somewhat fascinating, but it's quiet. Okay. There's a couple different ways you can picture this. Here's my personal favorite. Okay? I have to multiply everything in this trinomial by both the things in this binomial.
So it'd be x cubed.
Hold on, don't start yet. So I have to multiply all of this by x, and then separately I have to multiply all of these by minus 3. So it's going to look something like this. I can rewrite this as x.
Wouldn't you really add the x? Not multiply?
You add the exponents, but...
Yeah, that's no, the x. Yeah.
Okay.
Wait, hold up.
So take a look at this step. I'm multiplying everything in this trinomial times the x, and I'm multiplying everything in this trinomial by the minus 3.
Times the x. Wait, what?
Okay, I have to multiply x times each of these,
Why did you put them?
and then I have to multiply minus 3 times each of these. So I'm writing it out as 2 separate steps.
That's not confusing at all.
Well, if I didn't write it out as 2 separate steps, I could do like these,
That's what I was doing.
and then I'd have to do these on the bottom. And when we start multiplying like 3 at a time, that's going to get too confusing.
How?
I got the
Which way?
answers.
Okay, so hold on. Now let me show you a trick for keeping the answer straight.
Oh.
You don't have to use it, but it will really help, okay?